Hello, today we are going to do these two problems from ICSE 2019. These are question number 3, part A and part B. Okay, so let's read the question and you try to do it on your own first and then unpause the video to watch the solution. Okay, the first problem. Simplify sine of A times the sine, this matrix here, sine A, then the next one is negative cos A and sine A, plus cosine of A, and then you have this matrix. I personally love matrices. They seem to come out from sci-fi movies. They are interesting. Okay, so let's go ahead and try this. So we should know that whenever we have a scalar is a fancy word for just a number or a real number. We multiply each of those elements inside with that scalar. So sine of A times the sine of A is sine of A squared. Negative cosine of A times sine of A is negative cosine A times sine A. And this one is cosine A times sine A is sine A times cosine A. And this one is sine squared A or sine A squared plus. We will be multiplying each of those elements with this number out here. So cosine of A times cosine of A is cosine of A squared. Then the cosine of A times sine of A is cosine A sine A. Lacking of space. This one is negative sine A cosine A. And this is cosine of A squared. Now we are going to add them. And the way we do it with matrices, let's check if they are compatible or not. Let's think of the dimensions. This one has 2 rows and 2 columns, so it is a 2 by 2 matrix. This one again has 2 rows and 2 columns, so it is a 2 by 2 matrix again, which means that they are compatible, they have the same dimensions. Okay, so we can add them, and the way we do that is we take this element, we add it to that element and write it over here in the top left corner. Okay, sine of A squared plus cosine of A squared. Let's write it as it is, of A squared. This is negative cosine of A, sine of A plus cosine of A, sine of A. And this one is sine of A, cosine of A, minus sine of A, cosine of A, and sine of A squared plus cosine of A squared. Okay, we notice that this is just 0, this is just 0. This one by the Pythagorean identity, it's 1, this is 1, this is 1. So we have the identity matrix 0, 0, 1. That's the answer. So basically this is I equivalent. Okay, or the identity matrix. Okay, let's go to the next problem. This is from coordinate geometry. M and N are 2 points on x and y axes respectively. This is a nice word. This means in that order. So M is on the x axis, N is on the y axis. P 3, 2, we know that coordinates of P divides the line segment MN in the ratio 2:3. Find the coordinates of M and N and the slope of the line MN. Okay, really nice. And we can use section formula for it, but what if I don't remember section formula? Okay, so we have another method. In fact, it is the method by which you can actually generalize section formula. And the way I'll be doing this, that I'll be plotting it. Okay, so M is on the x-axis, which means you go some distance away from the origin, but you don't go upwards. So this is M at some point x, let that be x coordinate, and 0. I know that one because it's on the x-axis. Then N is on the y-axis, which means you don't go right or left. You just move upwards or downwards along the y-axis. Maybe N is here, and we have the point 0, y. where y is the number of units to go up or down. Okay, so y is the number of units you go up. Okay, and we know that P, a point P, 3 comma 2, so 3 comma 2 maybe somewhere over here, divides the line segment MN, this line segment, in the ratio 2:3. What does that mean? Well, MN, the way I like to think of it is from M to N. Okay, so that's the way I like to think of it. From M to N. That's the symbol for array. So from M to N, what happens is this is 2/5 of the way here, and N to P, that's 3/5 of the way here. So 3 times some constant A, 2 times some constant A. How do we now do this? Well, we are going to use a very fundamental property in geometry, that is similarity. Okay, so we are now going to check for x-axis and y-axis distinctively. Okay, so let's see. What is this distance here? In fact, you don't need to know the distance formula. You just know the x-axis. The x-coordinate of this is 3, and the x-coordinate of this is x. So this must be 3 minus x. Okay, so final minus initial. Let's say you are going from M to N, and along the path you have this P, 3 minus x, because that's the final minus the initial. And what is this length? Well, final minus initial, you have to be consistent. That would be 0 minus 3, the x-coordinate of this minus that, that's -3. Okay, so now the key realization here is if you are going from here to there, you are going 2/5 when you are going from here to here, and 3/5 when you are going from here to there. Which means that 3 minus x, the ratio of 3 minus x to -3, is the same thing as the ratio of PM to NP. What's that? That's 2/3, which tells me that I can cancel them out because we are multiplying both the sides by -1 and -3, and 3 minus x is equal to -2, which tells me that the x coordinate is 5, and this is the x coordinate of M. What about the y coordinate of y? We'll use the same exact logic. Maybe it's getting too crowded in here. We'll use the same exact logic. This is M, x, 0. Okay, what is this one? So let's say you are going from N to P. Okay, so final minus initial, 2 minus y, that's the y axis, that's the distance or amount you move in the y axis. And this one, final minus initial, 0 minus 2, that's -2. That's how much you move in the y axis, along the y axis. And probably I will get myself some space here. Okay, very nice. Okay, so now 2 minus y and the ratio of 2 minus y to -2, what is that equal to? Well, by similarity, that would be equal to the ratio of this NP to PM. Okay, so that is just 3a to 2a, or 3/2, which tells me I can cancel it by multiplying both the sides by -2. 2 minus y equals -3, which means that 5 equals y. Very nice. So I have found the coordinates of P and, okay, so I was asked to M and N. So coordinates of M is at x coordinate 5, y coordinate 0, and N is at 0, 5. Okay, now we need the slope of the line MN. The slope of the line MN is basically defined as rise over run. The slope is rise over run. How much you rise over run, or you can change in y or change in x. Okay, so when you go from N to M, what is the change in y? Well, first you were at 5, then you went to 0, so the change in y is -5 because you went down by 5. So that's -5 over, what's the change in x? When you go from N to M, you are going from x equals 0 to x equals 5. We found it right now. This is 5. So you are moving ahead by 5 to the right by 5. So your x value is increasing by 5, and that is negative 1. That's the slope. So the slope denoted by m is negative 1. That's it. Yes, we solved it. Thank you for watching.